guys, previous video I talk about the basic capacitor theory which connected parallel condition and series condition. Here I am going to talk about the capacitance of the capacitor and the energy of the capacitor. First I will going to talk about the capacitance of the capacitor. See, terms of the capacitor. When considering this capacitance of the capacitor, it defined as charge stored per unit, charge stored per unit potential difference change. Because here in this stored charge and its change potential difference, then we can identify the how the capacitance of the capacitor change. Okay, this defines as a charge stored per unit potential difference change. Okay, here simply we can understand this condition. Here this is a capacitor, then this capacitor has a q amount of charge, then and this capacitor potential difference we consider as a v. Then we can write the capacitance of the capacitor. I get C is the capacitance of the capacitor. C equal Q over V. This is the capacitance of the capacitor, and this is the change of the potential difference because of the Q amount of charge. This is the capacitance of the capacitor. Then we can rewrite this formula like this: Q equals CV. This is the main formula that we have to apply some corrections in the capacitors. Then we know that we can define these formula parameters like this. Q means charge stored in capacitors. Charge stored in capacitor. Next one is C. No, you know what is the meaning of C. C is the capacitance of the capacitor. Next is the V. V means voltage across the capacitor. This is the main formula that you have to identify and put this formula to some corrections in the which are familiar with the capacitor. Okay, next one is the energy of the capacitor, which is that energy of the capacitor. Here which formula is equal half CV square. This is the main formula for the energy of the capacitor. We can change the formula for the various situation with using Q equal CV. Okay. Using a Q equal CV, we can write equal for half C V square. Then we can write this formula like this two type as well. Okay, it is like this, equal half QV, and other formula is half Q square over C. This is the other two types we can write, two types formula that we can write with using the equal half CV square. Next one is it is very important formula for parallel plate capacitor, which is E, which is for the parallel plate capacitor. Parallel plate capacitor, which means that C equal A epsilon over D. This is very useful formula for the capacitor, parallel plate capacitors, which means that A is the area of the plate. A is the area of the plate. Epsilon is the permittivity, and D is the D means this is the D, distance between the two plates, and this side is the A, area, distance and permittivity of the parallel plate capacitor. These are the main formula that we are using for the capacitor's coefficient and solving the problems. Okay, these are the things that you have to know for solving the coefficients. If you like this video, thumbs up. See you around the next video.